All right, welcome back everybody to the fourth week of the Intro to Programming course with our program called Tech Bytes. Or if you're coming back way from early on the summer months of June, this is the 12th week of the Python session, meaning we have officially, likewise in our web development course, we have hit the 12-week mark, aka the 3-month mark for our Python session. Truly crazy how time flies, guys. We have covered so much, made so much, learned so many awesome things, and we're putting these new concepts into application each and every day, such as through our rock, paper, scissors games we have been working on for the past 2.5 weeks. And without any further ado, on to the next 3 months, right? So let's get started. All right, so if you do not already know me, guys, my name is Rayan Siddiqui. I am a senior at James B. Corner High School. Yes, indeed, school has started for me as well for the past 2.5 weeks. This is my 3rd week now, and I'm assuming if you're in District 54, your school started as well. So good luck to you in your new endeavors. A little about me, I love to code. I've made various apps for the app stores. I just released one this past weekend, actually. I love to program, made several websites, and I'm really looking towards content creation, making videos for my talk show, my YouTube channel, and writing articles. As always, if you want to learn more about me, you can always check me out on my website at rayansiddiqui.com. All right, so let's get down to today's agenda. First things first, we're just going to do a little reminder about our new schedule in case you missed our last week's session, because our timings will be changing by a little bit. And then we will go on to our daily fun fact relating the programming language which we are studying to a cool fact in our world, making that connection of how computer science is truly a worldwide thing. Then we're going to go over a quick correction. If you remember from last week, we left off on the part for our rock, paper, scissors game in the sense that we were trying to add the scoring system. However, we sort of ran into an issue, and today we'll go over that correction, make sure everything is smoothened out so that you can get your game working a-okay. And then we're gonna just do a quick overview of the whole project. Obviously, this was a 3-week almost project now. We did a lot with this project, a lot of code for sure. So just go over any misconceptions. I'll do a quick overview of the code once again. And then if you guys see this little if statement, we got here some logic, meaning that class time remaining is a Boolean. So I'm saying if there is class time remaining, meaning if this Boolean is true, then we're going to get into our next unit per se of recursion and how we can implement that, talk about that, have a discussion, and all that good stuff. So without any further ado, let's get to it. All right, so first thing is our schedule for the upcoming month of September. So today is August 31st. However, tomorrow is September 1st. Crazy how time flies. And our schedule for Tech Bytes will be changing a tad bit. So we are aware that everybody's school has started now. District 54 is full on their way. This is their 2nd week going on. And so is D211. This is now their 3rd week, as well as for me. But we have noticed that more people who want to join our course, they aren't able to attend, mainly because District 54 schools are still going on throughout this time, which is why we have pushed back our schedule a little bit. And instead of starting at 2 p.m. on every Monday, we will now be starting from 3 p.m., working our way till around 4 p.m. So, guys, the basic idea is that the day will not change. We're still doing our Intro to Programming course on Monday. However, as you can see, we're going to be not doing it next Monday because of Labor Day. Hopefully, you guys have a good weekend. And then we will be making Intro to Programming course a bi-weekly course for the month of September, meaning essentially it will be happening twice during this month. However, if you would like to see more of me and my teaching through our different courses through Tech Bytes, you're always more than welcome to join us for the web development course, which happens every Wednesday at 3 p.m. as well, starting September 1st, tomorrow. And then our Hack Central program, where we talk about more advanced computer science topics, such as machine learning, will be happening next Tuesday at 3 p.m. And then this Friday, we will be having our teen trivia at 3 p.m. as well. So everything, guys, is now going to be starting at 3 p.m. along with the teen trivia, which you start at 5 p.m. So basic idea, everything starting at 3 p.m. The days are still the same. And yeah, I hope to get you guys on more programs. All right, so let's get down to today's cool Python fun fact of the day. That being that using Python and artificial intelligence. We found out that the artificial intelligence knew about the COVID-19 virus before we did. Now, let's just digest that one piece at a time. So we're saying that a computer knew about this whole pandemic, which has shifted our lives in unimaginable ways. The past 6 months, for example, how has life changed by a lot, right? Well, we're saying that a computer knew about this virus, right? Before any human did. And here are the details. So basically, using artificial intelligence and using the programming language of Python, we knew about COVID-19, just the virus, 10 days before the CDC, aka, if you don't know what the CDC is, I would say essentially they're like the health organization which we refer to for some statistics, for facts regarding COVID-19. So basically, artificial intelligence knew about the virus before we humans did. And in fact, it was 10 days before the CDC released any statement about the virus. So this is happening way back in, it is actually Christmas Eve, December 24th, I believe, 2019, and is when this occurred. There was a small company based in London. Their name is Blue Dot. Now, this company called Blue Dot, they had previously helped with tracking viruses in the past, such as Ebola, SARS, and other types of viruses. And out of the blue, their algorithm, which uses the programming language of Python mainly, it picked up something weird happening in Wuhan, China, which is essentially the origination of the COVID-19 virus. Now, how did it pick up something about COVID-19 when there was nothing about it on the news? Well, basically, Python is a very special language, which we've talked about previously, and Python allows us to do something called natural language processing. Now, what does natural language processing mean? Well, basically, it's how we can scan the internet and look for actual human words in English, and then we can make predictions using data sets. So essentially, the English words are the input, and then our output is some type of prediction. Now, in this case, we use Python and natural language processing in the sense that the input data was the airline ticketing data. So this company called Blue Dot, they were using natural language processing, and their input data was this airline data of where people were flying to and a lot of what was happening on the news. Now, keep in mind, in this fourth week of December, there was not that much about COVID-19 over the news. If you take a look at CNN, Fox News, whatever news outlet you prefer, there wasn't that much mention about this virus. I mean, sure, there may have been a couple of articles from some journalists about this coronavirus, which nobody really knew anything about. Well, this company, Blue Dot, their algorithm, which uses Python, picked up some sense, you could say, about this trend happening in Wuhan, China. And it picked up this trend in various different languages. So there was obviously more news circulating about this coronavirus in Wuhan, China at the time because it was a hotspot, which is why using this natural language processing, we are able to essentially take in any human language, such as Mandarin or English in this case, and then we are able to make a prediction. And using all of this data, this company called Blue Dot, they were able to identify some trace of pneumonia about COVID-19 in Wuhan, China. Now, these guys have previously even identified other viruses like Zika and Ebola, like we mentioned previously, and essentially they released a research paper about what COVID-19 is and something which their algorithm picked up 10 whole days. That's a week and a half, guys, before the CDC even released any statement. So it's truly crazy to see once again, like every week we do, that we can vividly see our programming language, which we are studying, being put into practical use each and every day. And to see it being played on such a large scale, especially relating to our everyday lives now, right? Because of how COVID-19 has affected us. Just take, for example, our Tech Bytes course, which has now been going on online for the past 3.5 months. It just shows how cool and the endless possibilities of computer science, and in this case with the language of Python, and how it was able to identify this virus before anybody in the world. So as always, hopefully you guys enjoy that fun fact. For sure, it is a relatable fact. As always, share with your friends, with your family. You know, these facts, they aren't meant to be boring. They're hopefully meant to spark some type of interest in you, get that light bulb going, you know, get that brain rolling at the start of our Tech Bytes session. And it's always good to see how we can relate what we're learning every single day. All right, so let's get down to our second item on our agenda, that being a quick correction from last week. Now, if you do not remember what was happening last week, guys, essentially last week we were continuing our rock, paper, scissors game, which we had been working on for the past 2 weeks. And last week's main objective was to get some more of personalization working for the game and to create a multiple round system, which we checked off. And then our third aspect was that we were trying to create a scoring system in the sense that we could keep track of the user's wins, losses, and ties. However, we sort of ran into a problem because our variables, which were holding the number of wins, losses, and ties we have, they kept on resetting because we declared them as a local variable. And the mistake which we were making was that we were not declaring it as a global variable. Now, there was some issue with the syntax, however, it was not that major. I will show you guys what the problem was in a little bit. But basically, all we had to do was declare our variables, ties, wins, and losses, outside of our functions so that we can access them everywhere throughout our program. And then, once we had declared them, initialize them with a value of 0, because at the beginning of a game, you do not have any statistics. And then inside of our function, wherever we are using those global variables, we must literally write out in Python global and then the variable name. This way, we are essentially telling the computer that, hey, whenever we reference a variable, for instance, like ties, we are referring to the global variable. So this way, guys, we are able to keep track of our score so that, say we win a round, the next time we play, the score is not reset to 0. And all in all, it allows us to have a nice scoring system, which we'll see in a little bit. However, just to clear any misconceptions, I'm going to do a quick example. You feel free to log on to the website as well to follow along with this example. It will be dropped in the chat. Here it is. And what I'm going to do is just make sure that we understand the difference between coding a global variable and a local variable. So here we go. All right. So I'm just going to write our objective for this program. So it's going to be the difference between a global and a local variable. All right. So I'm going to first create a local variable. So I'm just going to call my function start, and then remember end in open and close parentheses, colon, and then I'm going to create a variable called, I'm just going to call it local variable, quite literally. I'm going to set it equal to, say, a value of 10. And then I'm just going to print out the value of that variable. Then I'm just going to go below, make sure your indents are correct, and run this function. And we should see in our console the number 10 being printed out. And there we go. We do see the number 10 being printed out. Great. So this shows us a local variable. Now, if you forget what that means, basically, if I create a separate function, I'll call it new function, a very creative name, I'm sure. And then I'm going to try to now print our local variable. And now, since you can see this auto completion, we can't even see our local variable being completed. Well, that's because we can't access this variable because it's inside of a different function. So if I run the new function name, we're going to see an error, some red lines. And if we do, there we go. We see that name local variable is not defined, meaning that this variable has not been initiated or initialized. So how can we fix that? Well, if I go outside of the scope of my functions, like such, let's go above, and I create the variable, I'll call it just whole number, and I'm going to set it equal to the number 10. Now, what I'm going to do is print the variable whole number. I'm going to call start again. And if I run this, we're still going to get an error. And if I do, 1 second, stop it, rerun it. And there we go. Okay, so we see that nothing is being printed. Oh, 1 second. Yeah, okay. So if we run this function, since we are not defining our variable, since this is a global variable, in order to use it inside of our functions, what we have to do is type out global and then the name of the variable. So now I'm just going to comment this function out. If I hit run, we see the number 10 being printed out. Now this is because we are using this as a global variable. So what we're telling the computer, guys, is essentially in this function that, hey, we're going to be referencing, whenever we reference the variable whole number, we're talking about the global variable, in this case, whole number. So hopefully that takes care of any misconceptions. I will be sure to drop this this fiddle essentially in our Google Classroom weekly update as well. However, if there are not any questions, let's get going. All right. All right, so now I just want to do a quick walkthrough of our finished version of our rock, paper, scissors project. We truly covered a lot of concepts over the past 3 weeks. Those core concepts being we're storing input from the user in a variable, we're using while loops to make sure that we are continuously asking the user for an input, aka allowing us to have multiple rounds. We're using booleans, logic, if-else statements to evaluate the winners of each round. We're using a lot of parameters in terms of comparing and evaluating the winner of each round. We added some nice personalization as well, getting the user's name. And then we worked on a cool feature of the scoring system, which I'm just going to go over today in the context of our rock, paper, scissors game. So let's open up our rock, paper, scissors fiddle. There we go. And now if I do run this game, we should see it being correctly ran. So put my name in. We get some nice personalization. We're able to play, I believe we have it set at 5 rounds, if I'm not mistaken. Let's take a look. Yep, we're playing 5 rounds. So if I do rock, we won that round. And now here comes the cool part which we added and implemented this week, that being the scoring system. So if I hit paper now, we should see this ties variable still displays the number 1 because it should still hold the value of 1. If I do, voila, we still see that our old statistics are being displayed and built upon. So we have 1 tie, we have 1 win, and we have 0 losses. And if we keep playing the whole rounds, so scissors I'll put, oh, we have 2 wins, awesome. For paper, we have 2 ties, and I'll do rock for the last one. And we won. Looks like we did not lose any games, which was awesome. And there we go. So here is the finished product, guys, of our rock, paper, scissors game. A quick run through of the code, just one more time. We had this initialize function called start run game, in which we're asking the user for an input, asking them for their name to make the game a bit more personalized. Then we're using this while loop to run our game 5 rounds. And this is where we call our initiate game function, through which we are getting a random choice from the computer to be generated. And then we're getting the user's choice. Then we are using another function, passing in parameters as values in order to evaluate who won the round. And as you guys can see, we have some multiple if-else, if-else statements here comparing who won the round. So if there are not any further questions, it was truly a cool project. We are definitely going to be start making even bigger and nicer projects in the future. Be sure to show this to your friends, family, always have to see a finished product. And this will also be linked in our Google Classroom updates as well. All right, then let's move on. So it looks like that our if statement at the beginning of our agenda today, we had an if statement saying that if we have time remaining, we can get down and talk about some new topic, a new unit, which we will be starting on and continuing throughout the weeks. This will be sort of a side unit, which we will be doing on top of some projects, and that is recursion. So let's get into what is recursion. Now, this week, I do not want to get into the super specific details, but we're going to talk about some generalities and do a quick example. So, if you have not heard of what recursion is before, recursion is the idea of being able to, in computer science at least, being able to call a function inside of that same function. So if we take a look at the bottom right here, we have this quick image we have. This is a function. You could ignore the function name. This is a different programming language called Java. But we have this function, and then we're calling that same function from inside that same function. Wait, that's a lot of the word same, right? Well, if we take a look at the logic going on right here, we have a function called recursion. We're calling recursion, passing in some parameter, as we know, and since they are between the parentheses. And then we're calling that function again. Now, immediately you might think, wait, are we calling the function infinite amount of times? Well, no, because usually when we do recursion, we have something called the base case. Now, the base case is right here. If we take a look, if I turn the pointer tool on, this is the base case. Now, the base case is what allows us and ensures that our function is not running for an infinite number of times. And basically what happens is that once we have declared and added in a base case, which is usually in the form of an if statement, we are able to ensure that our function does not run multiple hundreds or even an infinite number of times, because we are usually returning a value, which is then returning a separate value, which is then returning a separate value. Now, if that sounds confusing, do not worry, because we will be talking about this more throughout the next week as well. But let's talk about some of the applications which this topic of recursion has. One of the largest being mathematical problems. So one thing in general is that to develop this awesome love for computer science, you gotta love math as well. And today we will be talking about a bit of some advanced math, but it should be doable especially. And the basic idea is that we use recursion a lot in computer science when performing mathematical operations. Something next week we will talk about called Fibonacci sequence. If any of you guys know, you know what that is. And something which we'll talk about today and do an example with, that being factorial. So without any further ado, let's get into that. All right, so I'm going to open up the whiteboard and sort of go through what a factorial is, just to make sure that we are all on the same page. Everybody quick minute, all right. So I'm gonna hit the door tool. All right, so say we have a problem, whoops. So say we have a problem saying evaluate what is 3 factorial. So evaluate 3 factorial, like such. Now, in case you do not know what factorial is, we're gonna do it, no worries. So this symbol of an exclamation mark, this is what we call a factorial. This signifies to us that, hey, we are supposed to do the factorial of that number before. So in this case, we're gonna do the factorial of 3. And guys, excuse the bad handwriting, writing from my mouse, and keypad is not that easy. Like such, all right. So now we actually have to evaluate this problem. How do we do that? Well, the basic idea is like this. Since we are being asked to evaluate 3 factorial, what we have to do, actually I'm just gonna type this out, I think that will appear nicer. We have to do is, since we have 3 factorial, What that means is that we multiply 3 by every preceding number. So in this case, we do 3 times the preceding number of 3, which is 2, times the preceding number of 2, which is 1. And then we stop at 1. So what is 3 times 2 times 1? That is 6. Let's do another example. Say we have to evaluate what is, we'll do 5 factorial. Well, we do 5 multiplied by every preceding integer behind 5 until we get to 1. So 5 times 4 times 3 times 2 times 1, which all the value is to, let's see, 20, 60, 120. Once again, key point, we're stopping at 1. And we'll do one final example. Say we have a number like 7, same idea. We're doing 7 times 6 times 5 times 4 times 3 times 2 times 1. And if you want, you can evaluate that. That is some number. Once again, we're stopping at 1. And now, those were some nice numbers, right? Like, hey, they're between, like, they're less than 10. We could eventually do them if we write it out, right? Well, what if we have some huge number like 872? So if somebody tells you to take the factorial of 872, well, you would be there for a pretty long time, especially if you do not have a calculator. So that would literally be 872 times 871 times 870. And I'm not going to go on because we're going to be exceeding the class limit we have. And that keeps on going on and on and on. Well, using this idea, which we talked about briefly today, of recursion, of being able to call a function recursively, aka calling it again and again and again, this problem can be solved by a computer in less than a second. Well, how though? How can a computer solve it so quickly? Well, we're going to use that idea of recursion. So essentially what we're going to be telling the computer is that, if I move this toward the side, oh, 1 second. Oh, where's the whiteboard? Here we go. All right. So if we are going to, just going to move this like there. All right. So here is the basic idea of how we can solve a problem like take the factorial of 872. Well, let's see. Oh. So here is the basic idea. Say we have a function. We're going to say our function is recursive. We'll call it do factorial. And then we're going to ask the user to pass in a value, aka in a parameter. We'll just call it number. And guys, right now what I'm writing is just pseudocode, meaning it's not real code. I'm just going to like essentially plan out our idea, getting the brainstorming phase done, getting our idea on paper. So what we're going to do is tell the computer to do this problem for us. And to do that, we need some type of base case, which will make sure that our function does not run for an infinite number of times. And then we're going to need an else statement ensuring that we call our function recursively, again, in the terms that we're calling it over and over. So we're probably going to have to return something, right? Well, let's think about what that something is. So we want the computer to multiply every preceding number behind 872. So let's think about this in a mathematical sense. So we want the computer to do is multiply the current num, which is, in this case, the parameter number. And then we want this number to be multiplied by, this is a multiplication symbol right here, being multiplied the number preceding. How can I tell the computer to multiply by the number preceding? -1. So the number -1. But there's something missing, the recursion. So what we're going to do is tell the computer to call this function again for the number less, one number less, or the number preceding, right? But right now, we don't have a base case set up which will ensure that our function actually returns a value at the end. So we got to think of that. Our base case is going to be an if statement. We're going to check if our number is equal to something. In this case, right now I'm going to tell you what it is. That's 1. And then we're going to return 1. Now, you may be confused. Why did out of all the numbers, did I choose the number 1? Well, how about we go through this and do an actual example in sort of a pseudocode fashion, right? So say I'm going to call my function. I'm going to call, let's do some right here. So I'm going to call my function called do factorial. And I'm going to say, compute the factorial of 5. Now, we previously did 5. We know that the answer should be 120. So let's go through the logic of the computer. So I'm just going to draw this out, actually. It's going to be nicer. So this function is going to be called. The number 5 is going to be passed in as a parameter. And then our function is going to check if our number equals 1, which 5 does not equal 1. So then we go to this else statement. And then the computer is saying that, hey, call that function again, but return, I'm just going to say return 5 times that do factorial function, and then 5 minus 1, so 4. And then it's going to call it again because 4 does not equal 1. So 4 times do factorial, and then 3. Oh, it is pretty hard to draw on the Zoom whiteboard. And then it's going to call it again. So it's going to be 3, and then 1 less, do factorial of 2. And then it's going to call it one more time. It's going to be 2, but then the factorial of 1. Now, here is where our base case will come into play. Once we pass the number 1 as a parameter into our function, it'll meet the base case. So our function is going to return 1. So once our function returns the number 1, 1 second. All right, and once our function returns the number 1, essentially what we do is backtrack, and we go through each of these functions once again, plugging in the value. So it's getting pretty messy to write on this whiteboard. So I think what I'm going to do is open up an actual fiddle, and we'll put this into actual practice. How about that? So here we go. I'm going to reuse that same fiddle we used earlier during the class. And then I'm going to code it. So we had the basic idea down. So I'm going to call it do factorial. And then I'm going to pass in a number, just like we had in our whiteboard. I'm going to add our base case. So if our number equals 1, return the number 1. And then if our number does not equal 1, here is where the recursive part comes in. We're going to return our number multiplied by the actual function do factorial minus 1. This is a lot of code, guys. What we're doing here is if the number does not equal 1, meaning if our base case is not met, we're going to call this function again and tell it, hey, multiply our number by the previous number. And then here is where the recursive part comes in. Now, if I do, for instance, just to see if this works, print out, we'll do the factorial of 5. And we should see the number 120 being printed out. So if I hit stop and run, we do see the number 120 being outputted because, well, actually, I think I type right here. So what we'll do is make some print statements to show what is happening. So we'll print out our number. Like such. And then we'll print out what our function is going to call. do that. All right, so how about we just print that out? And if I hit run, we see that our function is being recursively called, starting at 5, then calling the number 4, then calling 3, and then calling 2, and working its way backwards. And if we take the product of all 4 of these numbers, so 5 times 4 is 20, times 3 is 60, times 2 is 120, and we do see the number 120 matching, showing how this function, we can use that idea of recursion and math in this case to take the factorial of a really large number. So let's put this into case. So say we want to take the factorial of 100. That's going to be a pretty big number. I'm going to print it out. Factorial is, just for some nice purposes. And if I hit run, I'm going to take a quick second. We see a really big number being outputted. Well, that is expected because what we're doing is a lot of multiplication. We're doing 100 times 99 times 98 times 97 times 96 and all the way down to 1, which is a lot. In this way, guys, we can use this idea of recursion in order to simplify our lives and do complex mathematical problems. All right, guys. So today I just wanted to get our basic understanding down with recursion. Obviously, you finished up our rock, paper, scissors game. In case you had a mistake or a bug, I will be posting a fresh copy. But next week, we will be getting more diving deeper into recursion. We will definitely be mapping it out. I will try to figure out a way so that I can draw nicer. Maybe I might just AirPlay on my iPad. We'll see, so that we can see the visualization process with recursion and how that idea of calling a function inside of another function works. But today I just wanted to get you guys introduced and show you guys an application with the mathematical function of a factorial. But other than that, remember, next Monday is Labor Day, so I will not be seeing you then or the next Monday, but the Monday after that Monday of Labor Day. So if I just pull the calendar really quickly, if that's confusing, the next time I'll see you guys is September 23rd. However, if you want to catch me at some other place, you can always find me in the web developing course every Wednesday now from 3 to 4 p.m. And if you'd like, you're always more than welcome to join our Team Trivia or Hack Central as well. So guys, I hope you guys had a good time. Hopefully you enjoyed the fun fact. Show off your friends, show off your project to your friends, and be ready to come back and learn some more about recursion next time we see. Other than that, take care, and I'll catch you guys on the next one. See you guys.